Hello and welcome to today's lesson on friction in regards to the net force on an object on a horizontal surface. So previously we've talked about coefficients of friction, both static and kinetic, and we did some calculations in finding both either the normal force or the kinetic, the force due to friction based on your coefficients, so on and so forth. And then these were the answers to letters C and D as well in the previous slide. Today we're looking at a real-life example of forces in action. So a student attaches a rope to a 20.0 kilogram box of books. I'm going to underline 20.0 kilograms so we know it's there. He pulls with a force of 90.0 newtons at an angle of 30 degrees with the horizontal. The coefficient of kinetic friction between the box and the sidewalk is 0.500. We are looking for the acceleration of the box. So that's our end-all be-all goal. Alright, so to start this out, let's draw a picture and write down what we know. So I'm going to put my picture, ooh, I didn't mean to do that. Just going to eliminate that line. We'll add it again. So we have 30 degrees here. I'm going to put my picture up top, just to save space down at the bottom. But I have a 20.0 kilogram box. On this box, I know I have gravity pulling, because that's what gravity does. Pulls me down with an acceleration of 9.81 meters per second squared. So if I multiply 20.0 times 9.81, I'm going to get a force due to gravity equal to 196.2 newtons. Okay? So along with that, what else is happening is I am pulling this box. Love a straight line there. With a force of 90.0 newtons at an angle of 30 degrees. So I need this to be 30 degrees there. Now because I have an angle here, I can split this 90 newtons into its x and y components. So if I look at the y component here, I can find this using my trig function sine and know that the sine of 30 degrees is equal to my opposite angle, or my y over here, over my hypotenuse, which in this case is 90.0 newtons. And so then if I multiply 90 times sine of 30, I'm going to get my y value. And y in this case is equal to 45 newtons. So we have 45 newtons there. I can do the same thing for my x value. So my x, I can use cosine. So I know x, and I have cosine of 30 is equal to my x over, again, 90.0 newtons. And if I multiply 90 times the cosine of 30, I'm going to get an answer of 77.4. So cosine of 30 times 90 is equal to 77.9. My apologies. 77.9. So x is 77.9 right here. And I'm going to go write these down below so I have them. So I have a mass equals 20.0 kilograms. I know that my force due to gravity is equal to 196.2 newtons. I had a force applied of 90.0 newtons at 30.0 degrees, which means that my F in the x direction is equal to 77.9 newtons. and my F in the y direction is equal to 45 newtons. Alright, so a couple things I'm missing so far. I also have a mu, coefficient of kinetic friction, is equal to 0.500, and I know that mu sub k equals my force due to friction over my normal force. So I need to have a normal force in here in order to get friction, in order to get my acceleration. Because right now all I have is, I know that this is mu sub k equals 0.5, but that doesn't tell me how much friction there is. And so I need a normal force here. So I need this force going up this way. And I also need my frictional force going that way. Okay, so for my normal force, because my box is sliding across the ground, as shown in the picture here, it's sliding across the ground, so it's not going vertically in any direction. Because of that, that means that my force in the y direction, so my sum of the forces in the y direction has to equal 0. And so right now I know that gravity is pulling down, so I'm going to give this a negative sign, just so we have its negative. So my forces in the y direction are gravity, which is negative 196.2 newtons. I have a positive 45 newtons. And I have my normal force. All those combined need to equal 0. So if I take 45 minus 196, because they're opposites, so 45 minus 196 is going to give me a value of 196.2 is going to equal 151.2. And so that is going to be this normal force. So over on my list of things I now know that the normal force is equal to 151.2, and that's newtons, which is the same up here. So on my diagram, we're expanding a little bit. I have 151.2 newtons. And so now I have a coefficient of kinetic friction and I have a normal force. So now I can solve for my frictional force. So I can take mu sub k equaling my frictional force over my normal force, and I can move this across so I can get my frictional force equal to my normal force times my coefficient of kinetic friction. So in this case, that's going to be equal to 151.2 times my coefficient, which was 0.500. So my frictional force in this case is going to be equal to if I subtract those out, my frictional force is going to be equal to 75.6. Or multiply those out, I get 75.6 newtons. And so this is going backwards. So that's my normal force. So then I have force due to friction equal to 75.6 newtons. Okay, so we did my y values. They're all 0. What about my x's? My force in the x direction, I had 77.9 going to the right, so I'm going to make that a positive 77.9 newtons, and I have a 75.6 going to the left, so I'm going to subtract 75.6, because it's to the left, we're going to make it negative. That's going to come out to an answer of, so I have a net force of 2.3 newtons to the right. I'm going to erase this bottom work. So 2.3 newtons is pulling to the right in this case. So I'm looking for acceleration. So I have a net force, and now I can use F equals m times a. I know that my force is 2.3. I can solve this for a by dividing both sides by m. So I know that a equals F over m, which is equal to 2.3 newtons, divided by the mass, which is 20.0 kilograms. And if you divide those out, you get an answer of 0.17 meters per second squared. So that is, oops, I lied, not 0.17, 0.12. 0.12 meters per second squared. And because it's acceleration, we need a direction. So this is to the right, based on the diagram above. That is how you solve this question, dealing with the acceleration of an object pulled on a horizontal surface with friction. Here is, oh, that was another page for me to do work on. Oops. Here is another question identical to it. So in this question, a student pulls on a rope attached to a box of books and moves the box down the hall. The student pulls with a force of 185 newtons at an angle of 25 degrees above the horizontal. The box has a mass of 35 kilograms, and the coefficient of kinetic friction between the box and the floor is 0.27. Find the acceleration of the box. So I will let you work through this one on your own. When you get done, and when I close this video down, I will write the answer up here real quick. So if you're going to work on this one, please pause the video at this point, perform your calculations, and then if you play the rest of it, you will see the answer, which I'm going to write here right now. And so when you work through this, your final answer should come to 0.17 meters per second squared. And then you need to have a direction, so whichever way your picture is pointing, left or right. So I'm going to say to the right just for convenience sake. Okay, but work through that question and see how you do. You should come to an answer of 0.17 meters per second squared. Best of luck, and I will see you again tomorrow.